Hey folks, welcome back. This is Joel, and we've been talking about campus fabric in the last few set of videos. In this one, we will get to the final discussion, which is the fusion. Right? We'll talk about the fusion device, which is here on the top, and we will basically see how we can get our clients, right, which are connected to our fabric, right? How we can make these clients go out into the internet, how we can connect these clients to the outside world, how we can connect these clients to a data center, right? And then we'll also look into how these clients can talk to each other, more like a inter-VN communication, right? And then probably if time permits, we'll also talk a little bit about the DHCP process in the fabric as well, right? So that being said, I think we are all good to get started. Just to recap what we have done for folks who are basically coming to this video directly, what we have done in the previous set of videos is we have set up the underlay, which is the ISIS. We have set up the overlay, which is Lisp with VXLAN, and we also demonstrated the intra-VN communication, right, between the IT host and the sales host. And then we also checked the mobility, right? We verified that mobility works as well. That is, if you take one of the client and move it somewhere to under a different switch, right, we basically showed that the communication still works, right? The clients can still talk to each other, which means the roaming was working properly, which or Lisp mobility, right, is one of the very important features, and that works properly. Also on the sides you can see there are APs, right? I have simulated APs as well, access points. They are basically not inside any VRF, they are in the global routing table itself, and they are also able to talk to each other, and everything seems to be working in the fabric. So now we will mainly be doing the configurations on the border and the fusion, right? Because the Lisp is running only till this point, right, till the border, but after the border there is no Lisp, right? And on my fusion router there is no much configuration as of now. There is just an IP address on this interface, I guess, and there is a default route towards the NAT router, right? NAT router is not very much in the scope of our discussion right now. It's basically if you want to be more adventurous, you can just replace this NAT with a firewall, right? And you can replace it with a firewall which can do some kind of filtering before sending the traffic to the internet. In my case, I wanted to keep it very simple, so I've put in a NAT router, which means from the fusion, let's look at the fusion router and let's see what is there right now, right? This is my fusion. So let's see. So if I do show IP internet brief, there you go. So we've got the gigabit 2, which is connecting towards the internet, and I think there is one default route as well, which is sending the traffic towards the NAT router. There you go, right? So I can ping internet, which means I can ping one of the IP 4.2.2. There you go, right? It works. So that is good. And on the other side, if you look at the topology here, you see on the other side, on the gigabit 1, we have two important services. So obviously this is a very simplified version of data center, but if you have enough time and you want to experiment, you can probably spin up a proper data center here, right? You can probably put up, I don't know, maybe like a VXLAN BGP VPN data center as well, right? Or you can do traditional STP VPC, that kind of a data center as well, whatever permits, right? You can spin that up. In my case, I did not want to spend more time on that, so that's why I kind of kept one small switch here, and I put two services. One is the Active Directory, which is on this particular subnet, which is 254.0, and this is the DHCP service, which is running on 255, right? Traditionally, actual SD access solution, generally your DNAC also resides here. DNAC and the ICE and even the WLC will reside here, right? In our case, like I said, this is campus fabric, and we are not actually using DNAC to deploy this. That's why we don't have that. But technically, in a proper SD access solution, along with the fabric, you're going to have your DNAC, your WLC, your ICE, everything sitting here in the data center, right? All right. So now that you know a little bit about the topology, let's and also just a reminder, the same rules which applied here earlier, right, on the edge devices still apply, which means we really can't create sub interfaces here on the CSR100vs, right? We have discussed this in the previous video. You can go back and check. So that's why we are kind of like we'll be using what we have done in the past, right? We'll be using the bridge domains, right? So I've kind of configured the bridge domain on the gigabit 1 interface. Maybe I can show it to you here quickly, right? Show run interface gig 1, right? There you go. So we've got the give it a second. Yeah, there you go. So we've got the gigabit 1, and you can see the 2 service instances, and we should also have the bridge domain, which is 254, right, and the 255 as well, to cater to both of those services, right? All of this extra thing, so much is extra because we can't really simulate, or the sub interfaces don't work properly in CSR100Vs. So that's why this is the easier way to kind of replicate what sub interfaces would have done for us, right? So that is what I have right now. So on this interface, I'm getting traffic from both the subnets, which is 254 and 255. Both my data center services are accessible from the Fusion router, and both the routes are there in the global routing table. Great. So now that we have set the context, what we have to do is, what is our game plan now, right? First thing, let's go and configure the border, right? So on the border, what we have right now is we have the we have Lisp just running, right? Now what we have to do is, let me grab my pen. Yeah, so what we got to do is, so we have the Lisp running on this guy, right? But what we really need to do is, we need to somehow make these two guys talk to each other, right? And how do we do that? We are going to use BGP. In fact, we are going to use the VRF-Lite version of it, right? The reason is because it is not plain BGP, right? We have different VRFs here. On this guy, we have IT, we have what is that? Other one is your sales, right? And on top of that, you also have the global routing table. So we have the 3 important constructs here on this border router. So the routes which are in each of these 3 VRFs or 3 routing tables, right? How are we going to send it upwards towards the Fusion, right? So that is very important. And then we will also have to learn the routes from the Fusion inside as well, right? So both, it's like a bi-directional thing. So I'll have to send the routes of the fabric, campus fabric, out to the Fusion, as well as the Fusion will have to send its route to my routing tables. So how are we going to do that? Using BGP, VRF, VRF-Lite, right? So let's actually get started, and I'll try to explain as much as possible while we are doing it. So let's go to the border router and observe the interface which is connecting the Fusion is gigabit 4, right? So our game plan here is pretty simple, right? So let me just grab my notes here. I think it should be somewhere here. Yeah. So let me again draw here, right? So we've got our right. So we've got our Fusion, we've got our border. I said we have multiple VRFs, but we have just one single interface. And I also told you that we can't use sub interfaces. So the other only option which is remaining for us is creating the bridge domain interfaces, right? So we are going to use the same approach which we have done in the past. We are going to convert this, this particular interface. We are going to create 3, let me use probably 3 colors. Do I have 3 colors? Probably yes. So 1, and the same thing we are going to create on the other side as well. The second one is the black one, right? It's a global routing table, and the other one is going to be the, let's say, the blue one, right? So we are going to create, basically these 3, bridge domains, right? We are going to create bridge domain interfaces here, right? And I don't know, maybe we can use different bridge domain numbers here. We could use something like, remember our VRFs, inside the Lisp, right? The instance IDs. Let's just write all of that here so that we don't get confused. We have sales, we have IT, and then we have the global routing table where we have the infra VN, right? So the IT VRF, the instance ID which is used inside the Lisp is 4100, right? If you go back to my previous video, this is what we have used. For sales, we have used 4101, and for this guy, we have used something like 3000, I guess. Right? If I'm not wrong, that's what we have used. Anyway, so just to keep stuff simple here, what we'll do is, let's use the 3 bridge domains which we have to configure here. Let's use probably 100, right? This is going to be for sales. 101, this is going to be for sales, and then 100 is going to be for IT, right? 101 is going to be for sales, and let me check my notes. What have I used? Okay, instead of so I think I've used, let's use probably 300 for this guy, right? So let's use 300 as the bridge domain for the global routing table, right? So we are basically creating VRF-Lite BGP here, which means the BGP neighborships are going to be established. So from here, this bridge domain is going to establish neighborship with this one, the blue one is going to establish with blue, and the black with black, right? So that way we are having like literally three instances of bridge domain establishing BGP and exchanging the routes, and that way we can keep everything isolated, right? All the traffic or the VRFs are isolated here, it's going to be isolated here as well. Sweet. So let's get to it. Let's start by configuring our border first. Where is our border? Here you go. So on the border, first is we have to create that bridge domain. So let's do that. Let's quickly, okay, so Control F, right? So there you go. So we've got the gigabit 4, the interface which is towards the fusion. See the two service instances which are here. Let's also go and create the other one, which is I think we can add it here itself. Yeah. So here this is going to be 300. This service instance is for the global routing table, right? So let's create 300 here, 300 here. Great. So there you go. That's mainly it. Maybe let's put a no shut as well, so that we don't have to do that again. No shut and no shut. I think this is pretty much, I mean, we have done this before in the previous video, so I'm not going to spend much time explaining what we are doing again, right? So that's happening quickly. There you go. So that's good, I guess. So we have configured, or we have just enabled that part. Now we have to obviously go and create your we have to basically go and create your bridge domain interfaces, right? We have just enabled service instances, but we need to create bridge domain interfaces. So we've got 100, 101, and okay, this one is supposed to be 300, right? Let's change this to 3, and that's 3. Okay, so that's it, right? So just observe the IP addresses here and look at what we are doing. We are taking the first bridge domain interface and putting it inside the VRF. Okay, the VRF names are wrong, my bad. So let's fix that. The user one is supposed to be IT, right? This one is supposed to be what? Sales, right? Makes sense. And the last one, we don't have to put it in any VRF because it is in the global routing table. The rest looks good. IP addresses, right? You can use any subnet. I'm using a /30 subnet here. I'm using 10.1.113 to on the border side. So on the other side, on the fusion side, I'll have to use .14, right? Here it is .17. On the other side, I'll have to use .18. So normally in SD access or in campus fabric, people use /30 subnets to save the IP addresses, right? You don't have to waste because it's all point-to-point links. And the last guy I'm using .21. So on the other side, it's going to be .22. So let's do a no shut here as well, just in case. Sweet. So let's put that. So that's going to go in. Okay, looks good. Okay, so that's coming up. It should come up anytime now. So the bridge domain interfaces are going to come up. So while that is coming up, let's go and do the same thing on the fusion as well. Let's just grab this guy and keep it beside each other. Okay, so on the fusion as well, now the fusion side, first thing we will have to do is remember, we don't have anything. We don't even have the VRFs on this guy. So we'll go and put the VRF first, right? So it's going to be let's do that. So where is my fusion? Here, right? Because the VRFs are needed on this side as well, right? We spoke about this before. The VRFs are going to be there on the border, and the VRFs are going to be created on the fusion side as well, right? And the routes coming from each of the VRF from the border side will enter the VRFs, which we are going to configure now on the fusion side, right? So let's do that. So let's go to the fusion router. Let's clear the screen a little bit. First, let's create the VRF. Okay, so not much got copied. That's fine. Let's let me just quickly copy the rest of the stuff as well. And what else? So we need probably the address family, which is missing after that, and the last part is probably that. Okay, great, sweet. So we've got my bad, the VRF, I've been using the wrong names. Okay, so the VRF, this one, the internet, the user is supposed to be IT, right? The two VRFs, the same VRFs, and this one has to be sales, right? We have the two VRFs. Yeah, good. So 4100 was IT, 4101 is sales, and this is pretty much straightforward, right? Route target. We are basically doing route target. Okay, so let's actually, you know what, let's cancel this because let's do one thing. Let's just copy the same thing from here. So let me do one thing, show run section VRF, because we have the VRF configuration on the border, right? It's going to be the exactly same thing. So let's just copy this, right? So that's good till here. Okay, looks fine, I guess. Anything else? I think that's it. Yeah, so we're going to put the same VRF configuration on the Fusion side as well. I mean, my notes seems to have some different VRF names, so I just don't want to put in the wrong things. Okay, so there you go. So we've got the VRFs all settled in, which means now we are good to go and configure this gigabit 4 interface on the Fusion side. In fact, I think we can probably use the same thing which is there here as well. So let's do that. Show run section or show run interface gig 4. Right, it's going to be, yeah, it's going to be exactly same, right? Service instance 100, 101 and 300, exactly the same on this side as well. Technically, if you had proper Cat9 case, then you could have done sub interfaces. Since we are doing this emulation on a router, and since it doesn't support sub interfaces, we are taking this weird approach. All right, so let's do that. Okay, we'll have to put a no shut here. Sorry, not here. Let's probably put a no shut here. Okay, so that's good. So that went in, good. Let's also do the same thing for the 3 bridge domains. So that's going to be show run interface bridge domain 10. Sorry, it's 100. Then we have 101, and the other one was 300, right? So let's grab all of them. Not 200, 300. Okay, so let's do 100 first probably. Yeah, there you go. Let's probably put a no shut here. Paste. Let's go to the second guy, which is here. All right, and the last one is going to be 300 here. That's okay, my bad. All right, so I think that looks good. So we have done nothing complicated here. We have done the exact same configuration on both the sides, right? So we have set up the gigabit 4, right? The gigabit 4 interface. We have created bridge domain on both the sides, and so the next step would be to go and bring up the BGP. So before that, let's see why our bridge domain interfaces have not come up. We'll have to figure that out. Okay, so here it seems to be down. Let me try to see why. Give me a second. Let me try to fix that. All right. So it looks like it is down because my gigabit 4 is administratively down. So let's do a no shut for that guy. And a no shut. Probably same thing on the other side as well. All right, so by doing that, it should now come up. Yeah, there you go. It is coming up. So our bridge domain interfaces are coming up. Cool. So that's good. So let's get back to our border router and let's start with the BGP stuff now. Right? Pretty straightforward. I mean, people who know BGP, I think this is going to be a cakewalk for you guys. So yeah, let's check it out. Right? So where is my BGP stuff? Okay. Yeah. So let's probably maybe use a particular AS number here. We are going to do eBGP, right? So we'll use probably like 65,000 and maybe 65,002, right? So let's clear the screen a bit. All right, so let's start with some basic stuff, shall we? Yeah, so give me a second. Yeah, there you go. So this is the border router. So we are starting with router BGP 65,002. the router ID, right, loopback 0 is what we are using. Oh, before that, okay, let me do one thing. Let me cancel this. Okay, I have a feeling I don't have the relevant loopback interfaces, show IP interface brief. Okay, so this is something missing. Let me fix that. So you see right now there is only one loopback interface, and that is nothing but the /32 loopback, like a management IP of this guy's of the border router, right? But if you have observed in an XD access solution, or maybe let me probably open up that link and show it to you, where that took me some time to understand, but then I found it finally here. Right, for the DHCP to work, right, this is one of the prerequisite. What is a prerequisite? You need to, let me scroll down to the steps here on the border. Yeah, so this is where is the Anycast? I think this one probably. Give me a second, let me find that exact step. All right, so here I will again discuss this in detail when we talk about DHCP, probably at the end of the video. But one important thing is, if you look at this particular step, right, it says you need to configure the loopback interface for the Anycast SVI IP addresses. Remember, we have the Anycast gateways which we have configured. In our case, it is 172.16.10.1, 172.16 20.1, and 192.168.10.1. basically all the Anycast gateway IPs which are, you know, sitting here on the edges, right? The Anycast gateway IPs, we talked about this when we created. Maybe let me show it to you if you have forgotten. So if I go on any of the edges, right here, right, so sorry, this is, yeah, here you go, right? So these are my Anycast gateway IPs. So it's there on edge 1, edge 2, edge 3. On all the 3 edges we have the Anycast gateway IPs. Configure these guys on our Fusion device. Looks like there's some error over here. Okay, so when I copied the interfaces from my border, I forgot to change the IP addresses, so let's probably go and fix that first. Do I have it somewhere in my notes? I think I do. Yeah, there you go. So let's do this. So let's change the IP address to 10.1.1.14, 1.1.18, and the other one is probably gonna be this one. Okay, so the other one is going to be 10.1.252. okay, so that's good. I think that should turn off all those errors. Show IP interface brief. Yeah, that looks good. Okay, we should no longer have these errors. That's good. Okay, so coming back, we are on the border, and we just talked about the loopback addresses and why we need them. So let's put them up quickly, right, so that we can go to the next step. All right, so in our case, like I said, we've got 3 SVIs, right? We've got the 3 Anycast gateway SVIs. So the ones which we talked about here, right? So we are gonna use the same ones here as well. So you just need to create cancel, copy. Yeah, there you go. So I mean, the name of the loopback can be anything, right? You just need to create those dummy loopback addresses on the border, right? And again, like I said, we'll double click on this when we talk about the DHCP part, right? But for now, you know, just look at that. I think I made a mistake. I just reused that old VRF. Let me fix that. All right, so we have put in the required loopback addresses right over here. We've got the loopback 3000, 4100. This is for your VRF-Lite, right? It's an Anycast gateway, and the other one is for the sales, right? Again, just trying to make sure this point comes across, right? We are just creating this to help with the DHCP process. It doesn't have any other relevance at all, right? I'll explain why though in a more detailed way later. Okay, so now we are done with that. I think we are good to start with our BGP configuration. So let's get to that part. Okay, so like I said, we will do like a eBGP setup here, right? It's going to be VRF-Lite eBGP kind of a setup. So the first thing is probably let's go and configure the router BGP 6502. The router ID is loopback 0. All of this is pretty straightforward. The neighbor is important, right? So for the global routing table, remember we have created a bridge domain interface, right, which is bridge domain interface 300, I believe, and the subnet which is used is this one. On my router, on the border, it is 10. Let me just show it to you here. Do show IP interface brief, right? Okay, so this is the one which I'm talking about. Which one? This one, right? So for the global routing table, to establish the BGP neighborship with the Fusion router, we are going to use this particular interface and this subnet. So my bad. So let's let's copy that again. There you go. So that's the subnet, and this is all straightforward. The remote is 65,000. The update source interface which we are using is 300, right? Pretty straightforward. All right. The next is the address IPv4 address family IPv4 part of the configuration, because now we need to tell BGP what are we going to advertise for this particular neighbor, right? So that basically goes in now. So we are going to enable address family IPv4. We are not going to do VPN v4 because that and all will be MPBGP stuff. We are basically sticking to very basic BGP, that is VRF-Lite BGP, right? So address family IPv4, you've got your network addresses which you are advertising, right? And look at this, I'm advertising this loopback 0, right? Actually it is not really needed. I'm just advertising it just for doing some kind of testing later. This one is not really very much needed, but this is needed. Remember, so we have created that loopback 0, right? Let me just pull this to the right side. Yeah, the loopback 3000, right? 192.168.10.1. We are basically advertising that one over here, right? We created it here so that we could do this, right? You kind of get the point now. We created the loopback here so that we could advertise it in BGP. Okay, and I'll tell you why explicitly why we are doing this later. And then obviously we are creating a summary address for the subnet 192.168.10.0, right? This is because this is the subnet which is there in my global routing table, and whatever we are doing right now, this particular instance of BGP or whatever configuration we are doing right now, that is for BGP with respect to global routing table. We haven't yet gone inside the VRF, right? And this is the subnet which is in the global routing table, which is the AP VLAN or the infra VLAN. So that's why we are enabling it, or aggregate address we are sending it over here. And the other important part is redistributing Lisp, right? This is literally how, this is like the glue. Redistribution is kind of like the glue which binds our Lisp and BGP together, right? Because in my fabric we are talking Lisp, and outside the fabric we are talking BGP. How do these two guys talk to each other? By redistribution. Got it? So we are redistributing the Lisp inside the BGP over here, right? So that's pretty important. And after that, we also need to obviously activate the neighbor, which we already configured above. We are activating the neighbor and putting in some kind of a weight and stuff like that, right? Pretty straightforward BGP stuff. Right? So by doing this redistribution, now what we have done is we have given the external world a picture of our campus fabric, right? We are basically told, and we don't have to redistribute BGP inside my Lisp, because inside my Lisp, if you look at my topology here, I've talked about this before, right? When we were discussing Lisp a little, if there is any destination which is not inside the fabric, I will anyway send it to the border, right? So I don't really need to have more specific routes of all this of all this data center or the internet routes inside my campus fabric. So that's why we are not redistributing the BGP inside Lisp, right? Rather we are doing only in one direction. We are redistributing only Lisp inside BGP, because we want the outside world, especially this Fusion router, to have a understanding of our route. So that's why we are redistributing in one direction. Now the other direction is not needed, because my fabric devices anyway, they are going to use the border as the default gateway, right? It's kind of like a proxy. We are configuring this to be the proxy ETR, right? And that's the main job of the proxy ETR, to serve as a default gateway for all your Lisp XTRs, right? Anyway, so coming back here, so we have done, let's just quickly look at what we have created. Router BGP, this is what we have done. Pretty straightforward, right? We have created a routing process, and we have enabled routing for the underlay, and we have also advertised this one extra dummy loopback address which we just now created, and nothing apart from that. And we have obviously sent a summary address for this subnet, which is nothing but the global, it's in the global routing table, right? The next is for the VRF sales. Let's go and let's do VRF-IT, right? Maybe let's do IT first. How do you enable that? Address family IPv4, explicitly enable VRF-IT. The network here, the /32 address which we are advertising is this one, 172.16.10.1, because it's again, that's serving the purpose of why we created that loopback earlier. Then we are sending the aggregate address. We are basically advertising this 172.16.10.0, which is the IT subnet to the outside world. Redistributing Lisp, like we spoke about earlier, and we've also kind of got the rest of the neighbor commands. Pretty straightforward, right? So once that is done, only one more thing which is left is for the final VRF, which is VRF sales. Pretty straightforward, just like how I explained, only the IP addresses are going to be different. Here we are obviously changing 10.0 to 20.0 because if you look at my topology, like I have mentioned here, the sales subnet is 10.0, the IT subnet is 20. I think that's a mistake. Okay, let me actually fix that. Can I fix it? I think that's a small mistake which I should have seen. My bad. Okay, give me a second. Let me fix that. Great. Okay, I fixed that. So that was a small mistake. The sales subnet is supposed to be 20.0. It's still 20. Okay, that's bad. All right. So that's a small mistake. So I fixed it. IT is 10.0 and the sales is 20.0. Right. So that is done. So we have created everything from the border side. I think we are good. I don't think anything else is needed on the border side. So now let's go on the fusion side. Very much same what we did just now. We have to do it on the fusion side. So yeah, let's do that. Let's quickly check if our interfaces are all up, because we would need them for the BGP neighborship to be established. Show IP interface brief. And yes, all the BDI interfaces are up, right? The ones which are very important is 100, 101 and 300, right? Looks good. I'm just worried about this. Let's just double check this one. Show run interface. I want to make sure that the see, this is what I was worried. The encapsulation is supposed to be 300 because I believe that is what we have it on the other side. It's 300, yeah. So let's we need encapsulation 300 on this side as well. Let me quickly fix that. Interface BDI 300. And the encapsulation is going to be changed to what, 300, right? Else we'll have mismatched traffic, right? What about let me verify my gig 4. Yeah, gig 4, it is 300. Okay, so now it looks good, right? So we've got the encapsulation 100, 101 and 300. Here also it is nothing but 300. Now we have fixed it. So everything should look good. Let's actually do a ping and check that. Let's do that. So give me a second. Right. So before establishing the BGP part, let's do a ping. So let's ping what are the IPs on the other side. Let's check that. So let's do show IP interface brief. And let's grab this guy, which is 10. This is in the global routing table. Yeah, that works. Let's do ping VRF-IT, and in the IT VRF we should be able to talk to this one. So let's check that guy. Yeah, that works. And the last guy is supposed to be, I think, sales, and here it's supposed to be, I think, 18 if I'm not wrong. Is it 18? 17, sorry. So it's supposed to be 17. Okay, all looks good. So we are good to start with the BGP part on the fusion router. All right, so I think the router process you probably already know because we used it earlier, right? It's going to be, give me a second. Yeah, so let's go to conf mode here, and let's clear the screen a little bit to give us some breathing space, right? So all right, so the first part will be the router BGP 65000, right? That's the AS number which we are using here. The neighbor is 10.1.1.21 because this is the global routing table. 6502 is the remote AS, which is the border router, and BDI 300 is the update source here. We are done with that. Let's move on to the next part, which is enabling address family IPv4 for my global routing table. What I'm also doing here is, before doing this, let's create a route map, right? Because that's going to be important. I'll tell you why we need the route map. Right, route map is a very simpler way of advertising networks, right? What I mean to say is, what I intend to do is, let me grab this. Okay, so we've got the fusion here, we've got the border here, right? We've got what tables? We have three things here, right? We have the global routing table, this is the VRF, this is the IT, and this is the sales, right? Now we have the same VRFs on both the sides. We have it on the fusion, we have it on the border side as well. So what we want to do is, all the routes which are there here in the global routing table, we want to advertise it here, right? Advertise it to the neighbor, right? Similarly, all the routes which are there in this in the IT VRF, currently there are nothing, obviously, because I've just created the VRF. There's nothing actually, right? The only routes which are there are here. We have the DHCP, we have the Active Directory, right? And you know, so if you want to quickly advertise all the routes, instead of explicitly using the network command, right, we can use it, you can do this using route map. So that's what we are going to do now. So let me just quickly show you how to do that. So let's create a route map. Before that, before route map, because route map internally will be connected to a prefix list. So let's create a prefix list. I'm going to say IP. Let me probably go outside of this a bit, right? So we're going to say IP prefix list, and we'll call this as default, right? Let's call it as default. And the sequence number, probably if needed, sequence number say 5. We're going to say permit, and we're going to put 0.0.0/0. So any route, right? Everything which is there in my routing table, I want to send it down, right? So that's why I created that prefix list. Now let's go and create a route map, right? That's how you do it, right? You create a prefix list and attach it to a route map. So the route map also, let's give the same name, default, and now maybe say permit 10, and what is the match IP address based on this one, what we just now created, right, on the top. So we'll say match IP address prefix list, and let's take this and put it down here. Sweet. I think we are good, right? So now let's go back to our router BGP here, and we are good to go and put in the configuration for this address family IPv4, right? So we are saying network 0.0.0, right, which is basically all the networks, and we are redistributing connected as well, all the connected networks like I spoke here, right? Everything which is there in the routing table, I want to send it down to the border, right? So that is done. And we also, this basically means everything. When I say everything, even the static route, everything goes in, right? So that's why I have this prefix list added. So basically whatever is there in my routing table, I want to send it to corresponding VRFs in my border, right? So that's what it is doing. So let's paste that. Probably let's delete that, it's not needed. Okay, so that's done. So we are done with the global routing table. Let's quickly do the same thing for the VRF sales and VRF IT. So this is your sales, very similar to what we did right earlier. The only difference is the bridge domain interface. Earlier it was, I think, somewhere here, right, BDI 300, but for sales we are using BDI 101. And the route map, right, we are using the same route map again, which we created earlier, right? So that is done with the sales. And the final guy, which is going to be the address family, the last one is going to be for VRF IT, right? So pretty straightforward again, right? The only difference is the BDI 100 and it's default out here. So let's paste that. Awesome. I think we are good, guys. So so you can see already the neighborship is coming up, right? Looks like one of the neighborship came up somewhere earlier. Here you go. One of them came here, second one came up here, and the third one has come up here, right? Let's do some verification from our side as well, right? So we are on the fusion. Let me just clear the screen a little bit. Let me go back here. So how do you verify? We can do show, what are those commands? Show IP BGP summary, right? There you go. Because this is showing the global routing table. So there is just one neighborship, and you can see the prefixes are received here. If you see some number here, it means it is good, right? That was like basic CCNA class stuff, right? So yeah, so we are getting some prefixes, which means this neighbor is good. Let's continue. Let's do let's look at the routes itself. Show IP BGP. Let's just look at the routes. There you go. So in my global routing table, you see I have these many routes. There is a default route, and you can see I'm learning the route from the border. This has come from the border. You can see the AS number here. So that one has come from the border. These are all my own routes, and this one is also coming from the border, right? Remember that aggregate summary which we did? So this is coming from the border. So you can see the AS path here, right? That is pretty straightforward. Then we'll look at the VRF stuff. So show IP BGP. I think you guys know the command VPN v4. We have used this command a lot in MPLS VPN, right? So VPN v4 summary, all summary. Let's look at the summary first. Yeah, there you go. We are getting some prefixes, and these are the two neighbors, which are basically nothing but the BDI interfaces, right? This is BDI 100. This is BDI 101. Let's look at the routes also. Show. It's actually instead of doing summary, let's remove the summary, and there you go. So this is what we are learning. So we are learning from VRF-Lite, we are learning this particular subnet. Again, this is coming because of that aggregate summary command, right, which we did here. If you see here, we did remember the aggregate summary command. Because of that, it is coming here. You can see we are getting the route for VRF-Lite, we are getting the route for VRF sales as well. Okay, let's go and check on the border side as well what is happening, right? Because the neighborship, you can see the neighborship has all come up, all the three guys, the neighborship has come up. So here also we should have almost similar kind of okay, I think I pressed end by mistake, my bad. Alright, so here what we do is again same thing, show IP BGP summary, right? So there you go, that we have show IP BGP. If I remove this, we'll get to see all the routes in the global routing table. You see the 192.168 route is there. We've got the default route which we have received from where? We have received this guy from 65,000, which is my Fusion router. Okay, and similarly we should have show IP BGP VPN v4 all and summary, right? There you go. So this is basically, obviously this guy is not receiving any routes because Fusion doesn't have any routes in those VRFs, right? Right now, if you look at my diagram here, right, the Fusion, we have just created the VRFs, which is IT and sales. They don't have any routes. So that's why this guy is not receiving any routes here, right? Prefixes received is 0, right? Whereas on the other side, the Fusion is receiving because we have sent that aggregate summary. All right, so that's good.